Hey, my third grade mathematicians. Today we're going to continue to work on fractions. We are going to explain equivalence by manipulating units and reasoning about their size. So let's start with our problem of the day. In your packet, it is your application problem. Let's read this together. Everyone ready, read. The branch of a tree is 2 meters long. Monica chops the branch for firewood. She cuts pieces that are 1/6 meters long. Draw a number line to show the total length of the branch. Partition and label each of Monica's cuts. A. How many pieces does Monica have altogether? B. Write two equivalent fractions to describe the length of Monica's branch. So let's begin with what do we know? Yes, we know the branch of a tree is 2 meters long. We know that she cuts the pieces that are 1/6 meters long. It tells us that we need to draw a number line to show the total length of the branch and to partition and label each part of Monica's branch. And we know that we have to figure out how many pieces does Monica have altogether, and we have to write two equivalent fractions to describe the total length of Monica's branch. So first off, we know that the branch of the tree is 2 meters long. So let's draw a number line. And this number line needs to be 2 meters long. So let's start here with 0 meters and all the way to here with 2 meters. What whole number is missing? Yes, a 1. So let's put 1 meter there. So if she cuts them into 1/6 meters, then how many equal parts do we need to partition each whole? 6 equal parts. Very good. So let's partition the whole from 0 to 1 with 6 equal parts, and then from 1 meters to 2 meters with 6 equal parts. Okay, so we have 0/6 here. We have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, which is equal to 1 whole, 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6, which is equal to 2 wholes. So now it says how many pieces does Monica have all together? So we know that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So she has 12 pieces. Okay, so now let's solve the B part. On B, it says, write two equivalent fractions to describe the total length of Monica's branch. So let's think, how could we partition this to figure out an equivalent fraction? So I'm thinking that if I have 6, half of 6 is 3, so I could partition it into thirds. So from 0 to 1, I would have to have thirds. So there would be 1. So 1, 2, 3 parts there. 1, 2, 3 parts here. So what is equivalent to 12/6? Let's see. So this would be 0 thirds, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, and 6 thirds. So 6 thirds is equivalent, equals 12/6. And I want you to see if you can figure out another equivalent fraction. Remember, we can partition into halves maybe, or you could partition into 12ths maybe. So just some ideas. Send me your thoughts once you figure that out, and I'll give you an extra point on the leaderboard. Good job, boys and girls. So we're learning to explain equivalence by manipulating units and reasoning about their size. Okay, so on your paper, I want you to draw 3 holes, just like I have on the board, and draw 3 number lines. Now, you can pause your video while you're doing that. I'm going to continue. So each rectangle represents 1 hole. So let's partition the first one into thirds. So that would be 3 equal parts. So 1, 2, 3 equal parts. Now, let's double the number of units in the second. So if we have 3 and we double 3, that makes 6. So I'm going to do it just like this. So now I have 6 equal parts. I know my parts aren't very equal, but I'm trying my best. So what's our new unit? It is now 6. So right here we have 3/3. Now we have 6/6. So now, if we wanted to repeat this for the third rectangle, instead of having doubles, let's triple the original third. So if I have 3 and I triple 3, I can count by threes. So 3, 6, 9. So now I'm going to have 9 equal parts. So I have thirds, and then if I partition again, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. So this shows 9 ninths. So what is the relationship between the number of parts and the size of the parts? The parts keep getting smaller, don't they? Yeah, very good. Okay, I want you to get out your fraction strip that shows one whole. It should be in your bag with all of your other materials. I want you to take that fraction strip and I want you to fold it in half. Okay, just like this. Now I want you to open it up. How many equal parts do you have? Yes, you have 2 equal parts. Now I want you to fold it back into halves. And I want you to fold it in half again, just like this. So see how I just folded it in half again? How many equal parts do you think you have now? Right, you have 4. Let's open it up and make sure. So open it up, I see 1, 2, 3, 4 equal parts. So now, if we fold it back into fourths and we fold it again, what do you think will happen? If we have 4 equal parts now, we fold it in half again. How many equal parts will we have? I think you're right. I think there will be 8. So let's open it up and let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8. You're exactly right. So what happened each time we folded it in half? Very good. The parts got smaller each time we folded it in half. So each time we folded it in half, we doubled it. So we folded it one time, we had 2 equal parts. We folded it 2 times, we had 4 equal parts. We folded it 3 times, we had 8 equal parts. Very good. Okay, boys and girls, very good job with that. Let's keep moving. I want you to look at the drawing that I have up here. I want you to draw that rectangle on your paper. And remember that if you need to, stop the video and wait until you draw the drawing, then start it back. So draw the entire figure and write the shaded fraction of this. So 1/4 is shaded. Now, how can you partition the shape to make an equivalent fraction with smaller units? Think about that. Talk with somebody at home about that. Very good. You can take it and you can partition it right down the middle. Now, what is our fraction? We have 2 parts shaded, and there's 1, 2, 3, 4, 5, 6, 7, 8. 2/8 of this rectangle is shaded. What happened to the numerator and the denominator? Very good. We doubled the numerator. If we double 1, we have 2. If we double 4, we have 8. So it shows 2/8. Did the shaded region change? No, it stayed the same. Let's try it again. Let's take out this one, and I'm going to see if we can make another equivalent fraction. So if I partition through there and through here, make 2 cuts, now what part is shaded? 1, 2, 3. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3/12. Those are all equivalent fractions. And did the shaded region change? No. Do you see a pattern up there? I see we had 1 cut, 2 cuts, and then 3 cuts. And each time 4 doubled and we got 8. Then we tripled 4 and we got 12. Very good job, boys and girls. Just drawing that one line, we can have equivalent parts. So let's look at our guided practice. Let's look at the first one. This right here says 2/10 is equal to blank fifth. So 2/10. We need to shade in 2/10. So here's 1/10, 2/10. Now let's go straight down to here. If we shade in this part right here, we have 1 out of 5. So 1/5. 1, 2, 3, 4, 5. So 1/5. So 2/10 is equal to 1/5. So what happened to the size of the equal parts when there were fewer parts? Yes, whenever there were fewer parts, the part size got bigger. Okay, let's continue with the next one. So 1/3, so let's shade in 1/3. It says 1/3 right here, and that's equal to what? We can go straight down from there, shade in this part, 1, 2, 3, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3/9. 1/3 is equivalent to 3/9. So the whole stayed the same. What happened to the size of the parts when there were more equal parts? Very good. They got smaller. When there were less equal parts, they got larger. Excellent job. And this will be the same kind of work you'll have on your independent practice. So 8 students share 2 equal pizzas that are the same size, which are represented by the 2 circles below. They notice that the first pizza is cut into 4 equal slices. So let's cut into 4 equal slices. And the second is cut into 8 equal slices. So there's 4, and now there's 8. How can the 8 students share the pizza without cutting any of those pieces? So let's think about that. We have 8 students. So one student could eat a piece, one student could eat that piece, one student can eat that piece, and one student can eat that piece. Do they all have the same size? Yes. So now let's look here. Could one student eat both of those pieces, and one student eat both of those pizzas, and one student eat both of those pieces, and one student eat both of those pieces? Yes, and they are all the same size. So 4 students will get 1/4. 4 students get 1/4, and 4 students get 2/8. 1/4 is equivalent to 2/8 because they're getting the exact same amount. Good job, boys and girls. And like I said, you're going to have some more work just like this. All right, so you're going to complete your problem set, and you are going to complete all of that on the front, and then I want you to complete as much as you can on the back. Very good job, boys and girls. Keep up the good work.